today's video, we'll be coding a mini project on how to convert speech to text. In this video, I'll be introducing you what is the exact meaning of speech to text and its applications. Post that, I'll be introducing the data sets or the audio files with which we'll be experimenting with going forward. Then I'll be introducing two methodologies on how we will convert speech to text. The first one is using speech recognition library, and the second one is OpenAI's Whisper Whisper model for conversion. After discussing these two methodologies, we'll try to compare these two methodologies and come to a conclusion on which one is better. Let's start by understanding the meaning of speech to text. So, speech to text is a technology that converts spoken language or the language via which we have conversations into written text. This is achieved using automated speech recognition systems or ASRs. These systems internally use machine learning algorithms, neural networks, and linguistic models to understand and transcribe the spoken words. Some of the most popular applications of speech to text that we encounter in our day to day lives are: the first one is voice assistants. For instance, Alexa, which tries to understand the command that we give to Alexa or the voice assistants verbally and executes it. The second one is transcription services. For instance, we are watching a movie and we want to convert that particular speech into text dynamically, is where we use these transcription services of converting or of getting subtitles while watching the movie. The second example of transcription services is if we have a recorded lecture and we want to convert that particular lecture into a text format, is where we use these transcription services of converting speech to text. Other example of transcription services is if we want to convert the whole Zoom call or the pre-recorded Zoom call conversation between the people who are attending the Zoom call into a textual format, that can also be done using these transcription services that leverage speech to text. Then coming to the third application, that is language translation or converting one language to other. For instance, we have a sentence in English language and we want to convert that particular language sentence into French language. This is where we use language translation and it leverages speech to text. The fourth application is in customer service, where we use interactive voice response systems, which automates the process of conversation between a customer and the agent, wherein the customer is not interacting with a live agent but with a computer based system. Now let's try to listen to the two audio files that we'll be leveraging while converting speech to text, while going through the whole process of speech to text conversion. The first audio or the speech file that we'll be using for this experiment is a small pre-recorded audio with my voice with the size of 1.1 MB. Let's try to listen to it.
Hey, good learning on the speech to text tutorial. Carry on the hard work.
The second audio file that we'll be leveraging for this particular experiment is a audio converted from a random YouTube video. I found a random YouTube video regarding overfitting in machine learning. I converted that video into an audio format or an MP3 format. This is the file that we'll be leveraging to convert the whole particular audio into the text. Let's try to listen to the initial parts of this particular audio.
Hey guys, and welcome back to my channel that is all about artificial intelligence, blockchain, and technology in general. Today, we're going to talk about overfitting in machine learning. What is it?
Prior to getting into the practical implementation on how to convert speech to text via speech recognition library, we'll first understand the meaning of speech recognition library. So, speech recognition library is a software toolkit that provides us with a functionality to recognize and transcribe spoken language into text. This particular library, the best thing about this library is we need not train any machine learning model or neural network models, because this particular library provides us with convenient wrappers for well-known public speech recognition APIs. A few of the well-known speech recognition APIs which speech recognition library helps us leverage are Google speech recognition, we have Microsoft Azure speech, we have IBM speech to text, but amongst all, we'll be particularly focusing on converting speech to text via Google speech recognition for this experiment. Now let's try to implement the process of speech to text using or leveraging speech recognition library. The first thing is we'll be installing speech recognition and PyDub. We'll be installing PyDub because PyDub is used for loading, exporting, and manipulating audio files. In this particular notebook, we'll be experimenting with both .wav audio file extension and .mp3 file extension. Speech recognition library only entertains or only takes as input .wav audio file extensions. Since we'll be using .mp3 as well, we need PyDub for converting that .mp3 to .wav file format, which can be used as an input to speech recognition library. Post that, we'll be importing the required packages and we'll be mentioning the path of the first audio that we need to transcribe, that is the small audio file of 1.1 MB. I have uploaded this audio file as test.wav. This file does not need to be transformed into any other audio extension. It can be used as is because it is a .wav extension. Post that, we'll be initializing the recognizer and then we'll be opening this particular file, that is the test.wav. This particular line of code will be listening to the data, that is the speech, and loading that particular audio or the speech into the memory. Post that, this particular line of code will leverage the Google speech recognition API and convert that particular audio or speech to text. And then we are directly printing the text, which says, "Hey, good morning. On the speech to text tutorial, carry on the hard work." This is the simple process of converting speech to text, wherein we did not use any machine learning. We did not train any machine learning or neural network methods on our own, just leveraged speech recognition library and the Google speech recognition API to convert speech to text. Now let's try to understand how do we transcribe larger audio files, that is the YouTube audio file regarding overfitting. This is our original overfitting.mp3 file on the left that we have uploaded. This particular mp3 file format has to be first converted into .wav because speech recognition does not entertain any other file format other than .wav. This is one of the first limitation of speech recognition. The second major limitation of speech recognition library is it cannot transcribe longer audio files greater than 60 seconds at once. If there are audio files greater than or longer than 60 seconds, they have to be split into multiple chunks and then processed one at a time. Let's try to go through the process one by one. The first is we'll be importing the required libraries. The second is we'll be defining a function to convert mp3 file format to wav file format, where we have two input variables. That is, the first is the mp3 file format path and the second one is the wav file format path or the output file format path. The second function is a simple transcribe audio function, which we have already seen earlier. That is, recognize the audio file that is coming as an input and using Google API to transcribe the particular audio file. Then the third function is creating multiple chunks of the larger audio, because the larger audio files cannot be transcribed using speech recognition library at once. So what we do is we have a split on silence function in PyDub library, which helps us dividing the a bigger audio file into multiple audio chunks using multiple hyperparameters. A few hyperparameters are minimum silence length. That is, how much of silence do we require to split that particular audio. There is a chance that if we split the audio randomly, we might lose out on some context. We don't want to do that. Hence, we are looking for a silence or a gap in the audio or the conversation that is happening in the particular audio, and split only when there is a silence. So the minimum silence length is a hyperparameter. Over here, we have given it as 500 milliseconds. Then the second hyperparameter is silence threshold. Over here, we are giving a silence threshold of 14 decibels. That is saying that if the sound of the audio is less than 14 decibels, we can consider this particular sound as a silence, else it will be treated as someone speaking. If the sound is less than 14 dB, let it split, else do not split. Then we have the third hyper parameter as keep silence. That is how much of silence should be there prior and post to a particular chunk that you are going to split. Over here, we have put that as 500 milliseconds, a total of 1 second. That is 500 milliseconds pre and 500 milliseconds post that. Once we do the chunking based on this split on silence function using PyDub, we have the audio chunks over here. On the left, if you see, we have converted that one particular audio file into multiple chunks of WAV, right? Then these all chunks go into a for loop, right? And then each of these chunks will get transcribed using this transcribe audio function using Google Speech Recognition API. So the whole process is first we'll be putting in the original MP3 path of our larger audio file, that is overfitting.mp3, which we uploaded. We'll be passing an WAV path where we want to store the converted file from MP3 to WAV. So we'll be passing both of these paths to convert MP3 to WAV. We'll only be having overfitting.mp3 in this particular area. Once we pass both of these paths over here, it'll give us the output of mp3. This particular function will convert the mp3 file into .wav format. This wav path will then be passed into get larger audio transcription on silence. We'll be passing this .wav file path into this particular function, which converts the whole larger audio into smaller chunks, and these chunks will be created over here. And post that, passing each of these chunks into a for loop one by one, we'll be transcribing the audio. Once we do that, I have printed the audio of each and every chunk one by one for your reference. So if you see, the first chunk is transcribed like this. Hey guys, welcome back to my channel. That is all about artificial intelligence, blockchain and technology. Today, the second chunk says that today we are going to talk about overfitting and machine learning. And so on, we have all the chunks transcribed. There are a few errors wherein the speech recognition library using Google speech recognition is not able to transcribe, and hence we see errors over here. Post that, what we are doing is each and every chunk has been collated to form the whole text, and we are returning the whole text and printing the whole text over here. And finally, we are printing the length, that is the character length of the whole transcribed audio or speech to text, which is 2791 characters in total. This is the process of transcribing larger audio files using speech recognition library and Google speech recognition API. Prior to implementing our second methodology of converting speech to text, that is Whisper, in the Python environment, let's try to understand this briefly. So Whisper is a family of speech recognition models developed by OpenAI. It is also designed to transcribe spoken language into written text. Whisper models are known for its high accuracy and their robustness in handling various accents and dialects. So it can handle multiple accents and dialects with a higher accuracy. These models perform well even in noisy environments, making it suitable for real world scenarios where background noise is a common challenge. That is one of the major advantages of Whisper, that since it can ignore the background noise in any audio and transcribe that text even with the background noise present with accuracy. Now let's try to implement speech to text using OpenAI's Whisper. The first thing that we'll be doing is installing OpenAI. Post that, we'll be defining a client object for us to interact with the Whisper model hosted on the OpenAI's website using an API interface, for which we also define the OpenAI's API key. Post that, we'll be transcribing the audio file into text using the client.audio transcription.create function. We'll be passing the audio file as an input and the model Whisper1 as the input to this particular function. The first thing that will be transcribing, first audio file that will be transcribing is the small audio file. That was the 1.1 MB file, that is test.wav, which is over here on the left. We'll be directly passing that as an input to this audio.transcriptions.create function with the model that we want to transcribe it through, and we'll get the transcription. That is, hey, good learning on the speech to text tutorial, carry on the hard work. Then coming to the second, that is the longer audio file, which was the YouTube audio file, namely overfitting.mp3. We'll be following the same process as we did for the smaller audio file. If you remember, when we converted the longer audio file using speech recognition library via Google speech recognition API, we had to first convert this MP3 file format into .wav. And since it was a longer audio file, we had to split the longer audio file into multiple chunks. Since speech recognition cannot handle, library cannot handle audio files greater than 60 seconds, a length greater than 60 seconds, we had to split and transcribe each chunk one at a time. But this problem is mitigated with OpenAI's Whisper model, which can take multiple audio file extensions other than WAV. So .mp3 is not a problem over here. Secondly, a file which is less than 25 MB, audio file less than 25 MB, can be used directly for transcription over here, and it give us the accurate results. So over here also we'll directly pass the overfitting.mp3 file and use the same function, that is audio.transcriptions.create function, passing in this new audio file, and we'll get the transcription over here. Now let's try to compare and contrast the two speech to text methodologies that we just learned. The first one is speech to text using speech recognition library and Google recognition speech recognition API, versus the second one, which is using OpenAI's Whisper model. As you can see over here, when we transcribed the text using OpenAI's Whisper, the length of characters that we got over here was 3859, that is 3859. Whereas in the earlier, in the first methodology, that is using Google speech recognition, we had just got a length of 2791, because while transcribing the chunks, the Google speech recognition faced a lot of errors, due to which it missed out on a lot of text. Hence, there is a mismatch in the number of characters, wherein Google, Whisper has a character length of 3859, and Google speech recognition has a character length of 2791. The second point, if we see over here, if we try to read this particular line, today we are going to talk about overfitting in machine learning. What is it? Question mark. Something that a lot of you people probably are wondering. So let's get into it. This is the transcription of OpenAI's Whisper model, wherein we are getting the proper punctuation marks and the aesthetics of the language are maintained. Whereas if we compare this particular text, similar text, which was transcribed using Google speech recognition, let's try to read it along. Today we are going to talk about overfitting in machine learning. What is it something? So over here, if we just focus on this particular thing, what is it something, versus over here, what is it? And then we have a question mark when we are seeing this particular output in the transcript of Whisper. We see that the meaning of the sentence is totally changed. Over here, since it has the proper punctuations present in OpenAI, versus in Google speech recognition, we don't have the punctuations, the meaning of the language changes a bit. This is one of the other advantages of OpenAI's Whisper model, that it maintains the punctuations and the meaning of the language better as compared to Google speech recognition. Now let's try to summarize the comparison of both the methodologies of converting speech to text. The first one is Google speech recognition and the second one is OpenAI Whisper. The first point of comparison is the accuracy with which the speech is converted to text. OpenAI's Whisper is better as compared to Google speech recognition. The reason is, as we just saw, Google speech recognition was not able to transcribe the whole text. Some of the chunks it missed while transcribing. Hence, with respect to accuracy, OpenAI is a clear winner. Coming to the preserving the aesthetics of the language, that is the punctuations. So, as we just saw in OpenAI's transcription of the speech, we saw that the punctuations are preserved and the meaning of the language is well defined. Whereas in Google speech recognition, since it's missing out on a lot of punctuations, the meaning of the language gets disturbed. So over here as well, in language and aesthetics, also OpenAI Whisper wins. The third one is input extensions. As we saw, we could only leverage audio files with .wav file or audio file extensions while we were using Google speech recognition. Whereas we could use .wav, .mp3, .m4a, .wma, and many more other extensions while giving an audio file as an input to OpenAI's Whisper. So over here as well, for the ease of use, OpenAI's Whisper wins. The fourth point of contention is the input file size. Since we could not use a longer file, audio file directly as an input to Google speech recognition, because the maximum length of an audio file that it can transcribe at once is 60 seconds in one go. Over here as well, OpenAI Whisper is the clear winner because it can handle a text or an audio file of up to 25 MB, and it makes our tasks easier.
Please do not forget to like the video and subscribe to the channel for more such informative videos related to artificial intelligence. Thank you.